Welcome to the new Smart Tweezers product preview. Today, we will discuss the features of the latest advanced devices product release. This is an unboxing and a preview of the new Smart Tweezers model ST5S, also known as the Colibri Pro. As you can see, it comes shipped in a box. Outside of the box, it is marked with a model number, a serial number, and a sticker that shows that the Swiss-made test leads are installed. Inside the box, we find the certificate of calibration, a plastic carrying case, as well as the product itself. Also included are an AC adapter, a USB cable, and in the European sets, a EU plug adapter. The manual, as well as the quick reference guide, are at the bottom. The supplied accessories may vary from country to country, and the manufacturer may change accessories from time to time. But right now, you will get what we have just seen. We will now put the box and papers aside for now. The unit is supplied in a plastic box. This is the main unit of the Smart Tweezers. As you can see, the device is small and fits easily in the hands. It has a USB port for charging, a control joystick, and straight leads attached. As shown by the sticker on the box, all leads are supplied by the Swiss company Idealtech, and their logo is visible on the test leads themselves. As per specification, test leads are made out of non-magnetic stainless steel and are gold-plated. They are attached to the tweezer handles by insulating shoulder washers, and the tweezer handles, in their turn, are multi-layered and provide for a 4-wire connection down to the test leads themselves, thus minimizing the effect of stray capacitance and resistance of the test leads and handle. Turn the unit on, the user presses the control. And as you can see, the screen is OLED, thus very bright, clear, and highly visible. The unit is currently in auto mode, as you can see here, but if it is not, it is advised to set it in automatic mode. The automatic mode is a fully automatic measurement mode, and it is specified by the A in the top left side of the screen and the AM in the top, meaning again that it is in automatic mode, and the AF means it's in auto frequency. Default frequency is here, specified in the top right corner. Now, if the device is not in automatic mode, it can be set there by entering the menu. Press the joystick to enter the menu. The first item is Auto Set. Once you press Auto Set, the unit is now in automatic mode. In automatic mode, the device is ready to take most measurements. For example, here I have a few components. One of them is a high-quality 100 nanofarad association capacitor. Also, I have an assembled PCB, so we can try onboard measurements, as well as some loose SMD components. So let's start from the SMD components. Make sure the unit provides good contact with the components. So as you can see, this is about a 9 microfarad capacitor. The next capacitor is about 20 to 21 microfarad. The next component is an inductance. So as you can see, it is at about 22 microhenry. Now the Socin through-hole capacitor measurement is at about 100 nanofarad. To take onboard measurements, make sure the unit has good contact because the board may be covered in lacquer. So here, we're going to be measuring a capacitor. As you can see, its value is at around 95 microfarad. Next, we will be measuring a large value capacitor. This one here is 1000 microfarad. Usually, for higher value capacitors, it is advisable to switch to manual C mode, meaning that the unit will know we are trying to measure capacitance. This can be done in two ways. First, you can do it via quick controls. The joystick is actually a 4-directional controller, and by pushing it sideways, you can change measurements mode, frequency, and test signal level. For example, to change measurement mode, push it left. Now it is in R mode. This is L mode, and this is C mode. On the other hand, it can be done through the menu. Make sure you are using the controlling element as a push switch and not as a touchpad. For example, in the menu, you can go down or up. In order to put the device in C mode, select Measure, then Mode, and then CAP. So this can be done through the menu as well, but it is usually quicker to go through the quick controls. Now in C mode, we can measure this capacitor. Decrease frequency to 100 Hz, and in this mode the device produces very stable measurements. The same goes for small inductances. Here I have an SMD inductance. In order to measure this, it is advisable to switch to L mode and increase the frequency to 10 kHz. So it's at about 1.2 microhenry. Pretty small. To return to the automatic mode, enter the menu and then press Auto Set. Smart tweezers also allow you to test diodes. For example, in this case, we can test junctions of a bipolar transistor. First, we need to switch the device into diode mode. Which is represented by a small icon at the left of the screen. Now, we can try collector base and emitter base junctions. As you can see, junction polarity is shown. If we turn the transistor, it shows the reverse polarity. Make sure the device is switched to the H or high signal level 1.0 volts, or otherwise the test signal level of the device will not be sufficient to open the PN junction of the diode and will show it as not diode. Functions of the Smart Tweezers is to measure equivalent series resistance of a large value capacitor or ESR. Now here we have the measurement of such ESR on the reference device, about 871 microfarad and a series resistance of about 150 milliohm. The Smart Tweezers is set to ESR mode with 100 Hz. And now we shall measure the ESR. As you can see, the result is about 150 milliohm, which is very close to the reference. Next, we will compare measurement results of precision components with the reference LCR meter, in this case 80810A, which has a base precision of 0.05%. For example, here we have a 500 ohm precision resistor. The resistance is about 500 ohm, almost to the zero. And our Smart Tweezers will show us that the resistance is 499.7 ohm. For another resistor, which is 5 kilo ohm, the reference LCR shows 4.99 kilo ohm, and the Smart Tweezers will show that it is 4.99 kilo ohm as well. For this low inductance Socian capacitor of 10 nanofarad, the reference meter shows 9.88 nanofarad. The Smart Tweezers show 9.88 as well. We hope you have enjoyed the presentation and will find the Smart Tweezers useful to your engineering work. For more information, visit www.advanceddevices.com.